Just to confirm that you're at the right session, this is AMZ201, ML infrastructure at Zoox that powers autonomous driving of robotaxis. Firstly, congrats everyone to making it for the reInvent. I hope you all had a great Thanksgiving. Today we would be talking about this topic, and I'm Avinash Koluri. I'm a senior solutions architect with AWS, supporting Amazon and its subsidiaries as a customer of AWS. And along with me today, I have Prasanna Padmanabhan. I'll let him introduce himself and talk more about this topic today.
All right, thanks Avinash. Good morning and welcome everybody. It's exciting to be here at reInvent and see this vibrant community grow. As Avinash said, my name is Prasanna. I lead the ML infrastructure organization at Zoox. My team builds the infrastructure that powers autonomous driving of robotaxis at Zoox. So the end of this talk, hopefully you will get a good overview of what Zoox is about and what are some of the things that we are doing today. And what are some of the machine learning use cases that we are currently handling at Zoox. And a brief overview of the ML infrastructure that powers these machine learning use cases. We'll then talk a little bit about some of the unique aspects of building machine learning infrastructure at an AV company. And we save the last for the best, where Avinash will share more context about how AWS is helping accelerate innovation at Zoox. So for folks who don't know, Zoox was founded in 2014 to make personal transportation safer, cleaner, and more enjoyable, and more importantly, for everybody. We are building a fully autonomous, all-electric robotaxi that is designed specifically for riders and not drivers. Our vision is to fundamentally reinvent personal transportation. Zoox is not just an updated car, it's a whole new form of transportation. Some of you may be lucky enough to see our robotaxi in the strip, but if you're not, if you're interested, we're going to showcase our robotaxi in the replay party on Thursday evening, so you folks are welcome to come join us. And if you're not driving your car, you can imagine that there's much lesser stress rather than looking at the traffic. I am sure that many of you will resonate with me on this, and rather use the time for whatever you want to do in a very spacious cabin like ours. Did you folks know that over 94% of the crashes that happen in the US is because of human errors? And our goal really is to make this technology reduce these errors and help save thousands of lives. And with our shared electric robotaxi, our goal is to also have lesser pollution and lesser congestion in urban cities like San Francisco and Vegas and across the world. Now, if you're thinking, okay, this mission and vision sounds very ambitious, you're right, it is pretty ambitious. But if you're questioning, okay, why are you then doing it? Here are the reasons why. Over 1.4 million fatalities happen globally because of crashes, which is unfortunate. I'm sure many of you here own multiple cars like I do, and guess what? Almost 4% of the time, those vehicles are in idle. Right now, my car is in at home, or many of your cars are in like garages at work as well. And even here, I'm not sure how many people came to this talk and parked your car in the garage in this casino. But again, guess what? Like 1/3 of the city traffic is caused by people who are searching for parking space. And I'm not even talking about air pollution and the insane amount of time that we are spending traveling and driving worldwide. So now that we are clear on the why, the how do we fix that needs a fundamental transformation. We had a great transformation from the past when we had like horses and carriages taking people from point A to point B to where we are right now with our present automobile. But we believe we need similar such transformation for the future, which is designed specifically for the riders. I'm going to give you or play a short video about Zoox, which will hopefully give you more context about why the future is for riders and not drivers.
Zoox is a fully autonomous robotaxi. No wheel, no front seat, no cramped back seat behind the driver. In fact, there's no driver at all. We built Zoox from the ground up in California, designed every seat and sensor configuration, sweated every detail from app to airbag. and trained the AI to anticipate every hazard city traffic can throw at it, rain or shine. We did it all for you, riders, so we could be a place to blast your own music or quietly finish that presentation. Do your makeup when you're running late, or have a snooze when you have all the time in the world. We'll let you stretch your legs and see the sky, and you'll find yourself wondering, just what kind of car is this? But we have a little something to tell you. It's not a car. Zoox.
All right, so what is our approach to solving this? Today we have two types of vehicles. One which is our test fleet, which is also the retrofitted SUVs that we use. These are mostly used for public road testing, mapping the geofences that we want our robotaxis to be operating in, and new city exploration. Some of you may know we are actively exploring Austin and Miami as the next cities that we want to be launching our robotaxis in. On the other hand, our purpose-built robotaxi is ground-up designed for autonomy. We are today using it for public road testing, but very soon you should be able to use this robotaxi to hail a service and use this as a service vehicle. Hopefully this gave you folks some context about what we do at Zoox, why we do what we do, and now let's switch gears into some of the machine learning use cases that we tackle at Zoox. The most common one, or the most obvious one, is autonomous driving, because we've already talked about that. So let's start with that, and let's start with perception. Think of perception as the eyes and ears of our robotaxi. These models helps us figure out who else is there in the road with our robotaxi. Are there other pedestrians? Are there other cars? Are there other animals? How do we detect traffic lights and traffic signals? We use that, or we find all of this by leveraging a combination of different types of sensors: cameras, thermal cameras, LiDARs, radars, and even microphones. And our perception models are capable of tracking and classifying hundreds of such dynamic objects in real time, including gestures. Like if one of our pedestrians are gesturing us to either wait or go ahead, we should be able to detect some of those things. And also detect distractions in our pedestrians or even riders when somebody uses their iPhone or phones to look at something. And be able to also detect things like construction zones and emergency vehicles and so on and so forth. So I'm going to show you a small video of how our perception stack perceives the real world. Here you see that we are able to detect pedestrians not just in front of our vehicle, but a very wide angle, pedestrians on the far left, pedestrians on the far right, and then you will soon see a pedestrian gesturing us to wait for them to first go and then get our robotaxi rolling. This is the place where we are picking up and dropping off customers in front of a casino, and as you can see, lots of pedestrians moving haphazardly across different lanes. And it's not just the pedestrians. You would very soon see a taxi not following lanes and moving to it. This is in San Francisco. Again, lots of pedestrians, possibly a lot of tourists as well. They're distracted in their phones, and folks also looking at taking photos and videos of this amazing place in San Francisco. All right, so that's perception. Again, to recap, perception models are helping us figure out who else is in the road with our robotaxis. Based on that, the prediction stack is responsible for figuring out what are each of those actors in the road going to do for the next several seconds. Are the pedestrians nearby? Are they going to take a left turn? Are they going to take a right turn? The vehicle besides us or the vehicle in front of us, which direction is that going to go? And our prediction models are responsible for accounting multiple versions of the future and then figuring out what is the final action that each of the actors are going to do in the road. So again, perception is responsible for figuring out who is in the road. Prediction is responsible for figuring out what will they do in the next several seconds. And then the next one is planner. Based on these output, planner is responsible for figuring out what should our robotaxi do. Should we go straight? Should we go left? And how do we execute our mission in a safe and comfortable fashion going from point A to point B? So planner is the one that's responsible for figuring out, should we change lanes? Should we accelerate? Should we brake? And it is the one that is talking back to the low-level controls of our robotaxi, which eventually is the goal is to complete our mission from going from point A to point B. As the name implies, it plans the route that we want to take from going A to B. The next one is around collision avoidance. Now think of this as an end-to-end system in a nutshell, meaning it's going to do predict, perception, prediction, and planner, but all as a redundant way of doing things, just for adding more redundancy, so to speak. The primary goal for collision avoidance is to predict collisions and, more importantly, avoid collisions from happening. Again, as I said, that is not already captured by our main AI stack because of this redundancy. Now, given that it's an end-to-end system, it is also going to do certain things like what the perception stack is doing. For example, it's going to detect road obstacles. It's going to detect occupancy grid, meaning which cars are in which lanes and what are they going to, which lanes will they be in the near future. And based on that, it is going to predict, will there be any collisions? And as I said, more importantly, if it detects such things, it is going to also come up and generate new routes that will ensure to avoid collisions. So again, the whole idea for collision avoidance is a redundant system that will ensure and or to predict and avoid any collisions in the first place. All right, but machine learning is not just used for autonomous driving within Zoox. There's lots of other use cases where we leverage machine learning. For example, generative AI use case is another thing that we are leveraging ML for. We use it for what is called scenario diffusion, or for creating scenarios for our simulation. So if folks are not familiar, we validate our AI stack through simulation before we deploy our AI stack to our robotaxis. And we are leveraging machine learning models to create those scenarios. In the past, we used to have humans creating those scenarios to validate our AI stack. Obviously, that's not scalable. So we are leveraging new novel diffusion-based model architectures to create these scenarios through machine learning. So similar to prompt engineering and ChatGPT, you can go say that, hey, here are the different scenarios that I want, and then the machine learning models help us create those scenarios. There's lots of other places as well. For example, foundational models. We are building several foundation models to do various different tasks. For example, identifying interesting scenarios, which are somewhat difficult for validating our AI stack, and use those scenarios as our common bank of, or a ground truth of scenarios that we want to validate our AI stack every time we update our code base. It is also useful for data mining. And what I mean by that is, if we want to find in all the different videos that our robotaxis have generated, in those videos, what if I want to find, hey, show me the video where there's an unprotected left turn in the strip road, lots of pedestrians, maybe even put in a cop and things in there. So these kind of tools are actually generated by these foundation models, which has helped us understand what is happening in the scene. Think of it as like scene understanding, so to speak. The other use cases are around triaging. Again, very simple process, you're trying to figure out where is a bug and what is the component that is causing a particular bug, and we are trying to automate those things with foundation models as well. Pretty soon, hopefully, we'll also be able to duplicate Jira tickets and stuff leveraging some of these foundation models. So as you can see, there's lots of use cases where machine learning is practiced at Zoox. Now we'll switch gears to what is the ML infrastructure that powers all these ML use cases? But first of all, why do we need an ML infrastructure team? What is the goal for this team? The goal for an ML infrastructure team is to reduce the end-to-end time it takes to develop and deploy machine learning models. That's a success criteria, right? The smaller the time it is, the better our ML infrastructure is, so that our ML practitioners can develop new models, better models, and that can do better predictions. But before we go talk more about ML infrastructure, I think many of you may already be familiar with this whole ML life cycle. Typically, you start with data, right? You collect data to build your machine learning models, and then you process that data to maybe clean some of that data, do some sort of transformations to maybe join different data sources, remove duplication, and so on and so forth, which is what I'm calling as the data processing step. This is super critical for machine learning models to work well. Your machine learning models can't do much without having good data. So it's critical for us to make sure that these two life cycles or stages in a life cycle is actually done well. The next step is around label and feature engineering. Again, as some of you folks may be familiar, even if you use a very simple model architecture, many times if you use the right data, you can do much better predictions. So label and feature engineering is another critical life cycle or stage within the ML life cycle. So let's assume that you have all the data that you want to create your training data sets. People then typically use their favorite training frameworks, PyTorch, TensorFlow and whatnot to train their machine learning models, which is the next step. And once you have trained your models, you have to validate if that model is making better predictions than what you already have in production, or validating, even if it's a new model, validating if those predictions are good. And once the models are evaluated and we know that it is good, we then deploy those models. Again, not rocket science, like model deployment is very similar to software release deployment too. So you need to make sure that you deploy in a rolled out phases like 5%, 10%, 50%. You want to do canary testing, you want to do red, blue, green, whatever terminology you use to ensure that the traffic is tested first. And then you serve your models to do better predictions, whether it's real-time predictions or whether it's batch inference predictions. And many times the output of the model serving infrastructure also is actually passed to the data collection stage, which is why it's a vicious cycle, right? The whole cycle moves on so that we can bake meta models every day, one step at a time. And the goal of this ML infrastructure team is to ensure that this whole cycle can be done as fast as possible. So for us to build a strong or a solid ML infrastructure, we need to first have a good data infrastructure. We need to then have a good training infrastructure. We need to have a good serving infrastructure. And finally, the one that connects all of those things together, which is foundational, which is the compute and storage infrastructure. For the next several minutes, I'm going to deep dive into each of these infrastructure and what we have set up at Zoox. So let's start with data infrastructure. Again, I've said this a few times, like machine learning models can only be as good as the data that we provide to it. But why is it so critical? Because there are so many challenges in this space. Let's talk about data management as a challenge. As an AV company, as I mentioned, our robotaxis record what's happening in the road with us, and there's lots of such data that we log to our data lake. Sometimes we wonder, okay, maybe Zoox is optimizing the ingest process, that we are more of a logging company, which also happens to do autonomous driving. So that the amount of data that we log is so much. And if you're not careful about building the right data management tools, you will end up spending a lot of money in terms of storage. So you need to make sure that you have the right retention policies and that you delete some of the data that you don't need in the future. And this is really where Amazon S3 intelligent tiering has greatly helped us too. At the same time, we want to also make sure that the data that we are storing is closer to the compute, so that we don't incur costs for like data transfer cost or latencies for the jobs to be running. The second challenge is around data discoverability. Again, when you have a lot of data, you're really trying to find a needle in a haystack, and this is where building right data discovery tools helps our ML practitioners find the right data sets that they want as fast as possible. So you want to build tools for creating data sets, managing data sets, and discovering data sets, both in an UI and in a library. The third challenge is around data availability. And what I mean by that is that it is the time it takes from ingesting all our data from our robotaxi to the time where this data is available for downstream use cases like analytical use cases or machine learning use cases. We need to make sure that is available as real time as possible. For example, sometimes when you're doing data analytics with rider data, you want to get that data as close as real time as possible. And finally, data governance. There's lots of PII data that we will be collecting as we open up our ride-hailing service, and all the camera data that we have from our robotaxis, which means we need to make sure the right people have right access for the right tools. So ensuring those access control policies, and more importantly, even having a trail of who is accessing what, is critical for data infrastructure. I'm now going to give you a very high-level overview or a design of how our data infrastructure at Zoox is set up. It all starts with our robotaxi, which is the one that gives us all the vehicle data and rider data. Rider data typically goes to a Kafka, which can then be used for various real-time analytical use cases. All our vehicle data is stored in S3, which is our data lake. And all of this data is then combined into a landing S3 table. So the rider data, vehicle data, all is in one place in S3. We follow a medallion architecture at Zoox, which is, again, leveraging bronze, silver, and gold table infrastructure. Beneath the scenes, we use Delta tables with Parquet as the underlying storage format, all on top of S3. Now think of bronze table as the table that contains all the raw data of our sensor data and vehicle data. And then based on that, we do various transformations for our silver jobs. Again, similar such transformations like cleaning, deduping, and joining with different data sources. And finally, all the summarized data is actually written into the gold tables. Now, why is this important? With the amount of data that we store, maybe the retention policies for gold tables can be different than the bronze tables. End of the day, gold tables is what is used for machine learning purposes and for data analytical purposes. So maybe you want to retain the tables in the gold tables for a much larger time, but maybe delete all the data from the bronze tables to a much shorter time. And some of the tools we have been using are Apache Spark. We use that extensively for creating training data sets for machine learning use cases. We use Amazon Athena for doing ad hoc data analytical use cases. And we've been using Amazon Open Search Service for storing our embeddings. We talked about data mining tools for scene understanding and doing things like nearest neighbor searches for data mining use cases with Open Search Service. So that's our setup for data infrastructure at Zoox. Hopefully with this infrastructure, our ML practitioners can create training data sets or for various analytical use cases pretty soon. So we'll switch gears to go to the training infrastructure. Similar to data being a gold mine, it is also critical to have a solid training infrastructure, because this is the one that's going to help unlock rapid experimentation and unlocking new model architectures. With the advent of deep learning and things, a lot of our models are becoming more complex so that it can make better predictions. So it's critical for having a training infrastructure that can enable these large-scale model architectures. I'm going to share some of the salient features of the training infrastructure within Zoox. First of all, it's all built on top of OSS frameworks. Many of our models are trained on PyTorch, specifically PyTorch Lightning. Some of our recent reinforcement learning models are starting to leverage JAX. And we also leverage open source Ray, which has made it super easy for anybody to do distributed multi-node GPU training. As I mentioned earlier, we have a large data sets or corpus of data sets. So our training data sets are extremely huge. So which means we need to have optimized data loaders to both reduce the time it takes to train a model and for better GPU utilization. So things like data parallel is all table stakes in the industry, and we've been leveraging that pretty well. Similarly, we've been using other things like mosaic data shards or S3 streaming, FSX for high throughput training use cases, and starting to leverage some of the network interfaces like EFA, Elastic Fabric Adapter, which makes multi-node communication much more faster as well. We also have a model repository which keeps track of all the models that are trained in our at Zoox, and has tons of metadata like who is training this model, how often is this model trained, what are the data sets that it's using, and things around like how much does it cost to train a model and things like that. We also have operational metrics like training time, error time, data loading time, or error rates, data loading time, etc. Now, why is this important? We can't make things better without measuring first. So it's critical to also have good model metrics for your ecosystem. Lastly, we've also invested quite a bit on experimentation tracking. It is critical for ML practitioners to keep track of all the experiments that they have run in the past. One, to reproduce it at a later point in time, or two, to share those ML experiments with other ML practitioners so that they can reuse their work. So yeah, that's our training infrastructure that is helping ML practitioners to train models. Once you have trained your models, your next step is to serve those machine learning models. So again, the goal here is to efficiently serve models on vehicle. At the same time, I've said a lot of use cases for off-vehicle use cases to have high-throughput batch inference use cases. So for serving, as I mentioned, for a robotaxi company that does autonomous driving, the inference optimization for the models that are running on vehicle needs to be super good. So this is where we've been leveraging NVIDIA's TensorRT ecosystem to make inference be much more faster on our vehicle. So essentially, we convert all our models from PyTorch to, there's an intermediate step to convert to ONNX and then to convert it into TensorRT. But as I call it again, there's multiple other models outside of what's needed for autonomous driving. This is where our cloud serving infrastructure comes into the base. And many of those use cases are batch inference use cases, so we need to make sure it works well with some of these high throughput use cases. Even here, we leverage Ray serve specifically, and we build our cloud serving infrastructure on top of Amazon EKS. Now, what does Ray Serve and EKS gets at is that we are able to use different types of like CPUs and GPU architectures. We try our best to leverage CPUs mostly for cost efficiency for our models, but then there are certain models which needs to run on GPUs for even model serving. Sometimes when we validate our AI stack, we want to make sure there is parity between what happens, what you see in the Robotaxi when we run our models with the GPUs in our Robotaxi compared to what we have in our cloud infrastructure. But at the same time, Ray Serve also provides functionalities like auto scaling so that you can get more GPUs when the demand is high and then give back the GPUs when the demand is low. It also supports things like model multiplexing, which is a pretty useful tool to have as well. For folks who don't know, you can load multiple models with the same or similar input types into the set of replicas so that you don't have to incur the cost of model initialization back and forth. So yeah, that's our serving infrastructure. And as I mentioned, for data infrastructure, training infrastructure, and serving infrastructure, you need to have a solid foundational compute and storage infrastructure as well. So again, the key use cases we are leveraging here is on the data side of things, building data sets, large-scale model training, and for batch inference in the cloud. So what are the technologies do we use for our cloud infrastructure? For the compute side of things, we use EC2 and EKS as the core backbone that is built on top of all the CPUs and GPUs that we leverage. For the storage infrastructure, we leverage Amazon S3 and Amazon FSx as our primary things in the cloud. But again, once you have those resources, you need some sort of a resource scheduler to manage these resources. This is where we are using Slurm. Slurm is an open source product, simple Linux utility for resource management. And this is the tool that schedules workflows and leverages these compute and storage infrastructure. Finally, we use Apache Airflow as our workflow orchestrator. Our ML practitioners leverage Airflow to schedule or to create DAGs, directed acyclic graphs, and use that to schedule workflows using Slurm into our compute resources. But maybe let's see if we can put all of these technologies together to see how does an end-to-end compute and storage infrastructure look like at Zoox. When our ML practitioners run their workflows through Airflow, the first thing that they hit is through a load balancer. And the load balancer is an entry point for many of the microservices that captures all the metadata. For example, again, similarly here, who are the ones who are creating the workflows, how long does it take time to run those workflows, what are the error rates for the workload. So we do a lot of accounting and monitoring these workflows as well. We also have a web UI that people can use to see the progress of these workflows. We also have an internal queue, mostly for redundancy purposes. If Slurm is down, at least we don't miss all those requests, and those requests are all queued up. But Slurm also has its own redundancy as well. We have a Slurm primary and a hot Slurm backup, which can be swapped pretty instantly for if the primary goes down. And internally, Slurm uses Amazon EFS and MySQL to store the state and various metadata as well. And finally, this is all the compute and storage instances. In the past, we have built our own data centers and had our own on-prem storage. And in the last few years, we've been leveraging more from AWS. And in fact, in the recent past, we've also thinking about what should our compute and storage strategy be in the longer term. And we tried to look at various different aspects to decide that. For example, what is the one that we should choose to foster innovation at Zoox? What is the one that's going to be cost effective? What's the one that's going to be reliable? And more importantly, are there any execution risk if we are building it on our own? And it's some sort of a no-brainer to choose AWS as our cloud service infrastructure. So with that, I hope you folks got a context about how all these four things, right from data infrastructure, training infrastructure, serving infrastructure, and compute and storage infrastructure, is powering our ML infrastructure, and which is again powering our autonomous driving of robotaxis. So I'm going to switch gear to talk a little bit about what are some of the unique aspects of building ML infrastructure at an AV company. The first thing that comes to my mind is around simulation. Simulation is the one where we have invested quite a bit to validate our AI stack before deploying those models to our robotaxis. I think this is one key difference between a traditional machine learning company and an AV company. You invest tons of things on simulation to validate those models that maybe a traditional ML company might have otherwise not done. And when we create those simulations, we deliberately focus on less common or more difficult driving situations so that we can validate our AI stack even on some of those edge cases. We have built a state-of-the-art simulation software that is able to create these virtual worlds that looks and mimics pretty much the same as your real world, right? The whole goal of doing this is that once we have validated our AI stack in a simulated environment, it should pretty much behave the same thing as in real world as well. So this is one of the key things that I see as difference between building an ML infrastructure for an AV company compared to a traditional ML company. The second one is that an AV company is super thirsty of GPUs. And our workloads are also very spiky. Now the graph here shows the number of GPUs that we have used versus I think a couple of weeks time window period of time. And for simulation use cases, we leverage tens and thousands of GPUs for that. And which is why, like as you can imagine, these GPUs are neither cheap, nor is it easy to get even from AWS. So we need to be mindful of how can we be more cost efficient, how can we be more efficient in utilizing those GPUs. We already talked about data locality in the past. We need to have our workflow or resource scheduler to do priority-based scheduling. What I mean by that is some of the more important workflows need to get access to the GPUs, and we have also enabled preemption so that if a low priority job is currently using some of the expensive GPUs, and when a high priority job comes in next, it can be paused and give way to the high priority jobs. It is also important to have a balance on how do you procure those GPUs? For example, you may want to use spot instances, which are much more cheaper, or sometimes on-demand instances, and sometimes even reserve capacity, so that you can guarantee the availability of GPUs. So balancing some of those things will also help you be more cost efficient. Lastly, for an AV company, we need to be super strict on inference latencies. We've talked about different types of models: perception, prediction, planner, collision avoidance. All these models needs to run several times within a second for us to have a great autonomous driving experience. Which means we need to make sure that our models are not too big, because if it does, it will cause inference latencies. But as I said, we've also trained with large-scale volumes of training data sets. This is where we need to invest more on making model inference much more faster on vehicle. We leverage techniques like quantization. For folks who are familiar, instead of leveraging, like say, floating point FP32, we've been leveraging things like FP16 and int8, which is reducing our memory needs and without having too much loss in accuracy, and be able to run inference much more faster. We also had different other techniques like pruning, which is essentially removing some of the layers in your model that's not super relevant to the predictions. But once we improve model inference latencies, what do ML practitioners do? They immediately train with larger data sets and make their models big. And that's exactly how it should be, right? The goal of an ML infrastructure team, as a recap, is to make the time it takes from ideation to productization, or that vicious loop that we saw earlier, to be as fast as possible. All right. With that, so far we have seen a little bit more about, hopefully you got to know more about Zoox, what we do, why we do, what are some of the ML use cases we have been using at Zoox, how is our ML infrastructure set up to support these ML use cases, and finally a little bit of what I find interesting building ML infrastructure at an AV company compared to a traditional ML company. And I'm going to hand it off to Avinash, who's going to talk more about how AWS is leveraging, or we leverage AWS to increase innovation at Zoox. Thank you.
Thanks, Prasanna, for those details. Am I audible? Thanks. All right. So now that we have understood a little on what's the need of the entire compute, storage, and as well as analytics in terms of understanding about how an AV company is actually powered. And as Prasanna mentioned earlier, there's a lot of use cases that are happening around prediction, perception, planner, as well as the inference latencies. So for all of this, one thing that is pretty much important is the compute. And that necessitates the call for the GPUs for all of these ML workloads to really scale. And with that, yes, everyone in the industry today needs more and more GPUs. And at AWS, we take a lot of audacity in terms of guiding through best practices, and as well as making sure that we leverage these GPUs in a much efficient manner and making sure they are not in the idle state. So for that, what we would recommend is there are few options. The very first one to start with is your on-demand capacity reservations. It's similar to your on-demand capacity within the EC2 instances, wherein which you could go ahead and procure a set of reservations that are happening to get these GPUs. And typically we are talking about P4s and P5s here. And these are all subject to availability. And then next, the spot instances. For example, if you have a workloads that are actually bearing with intermittent stoppage of the work, or that or your machine learning workloads can take a sort of a break when running a certain models, then we would recommend spot instances, and this is usually offers at a great discounts, but again these are also subject to availability. All right, now that we know that there are two different options, and what's the best one out of this? And the best one is usually the ML capacity blocks. This is our one of its new offering that launched past year, wherein which you could go ahead and reserve your capacity. So Zoox powers a lot on the ML capacity blocks in terms of leveraging and managing their entire GPUs. So let's dive deep a little more on the capacity blocks. So on the capacity blocks, the primary factor that is required in terms of getting the capacity is you need to mention your date, time, and number of instances, and that's it. Within that, AWS offers you a calendar so that you can pick and choose on what dates and how the availability is. You could imagine this something similar to like an hotel booking, where you go ahead and just mention certain dates, and then it will show up all the availability of the rooms in the hotel, and whichever is feasible to you, you'll go ahead and book it. In this way, there's at least a guaranteed on the capacity that you could procure in it. And some of the key use cases that has really helped Zoox in terms of their ML workloads is they were able to run the experiments way beyond, because they need not go ahead and reserve for a large or long-term capacity commitments, and they were able to immediately test how these experiments were going on, and further they were also able to fine-tune on these experiments on the model training. And then it also helped them in terms of launching it to the exact timelines within their simulation runs and also their milestones. And here is a quick feedback that we got from Kai Wang, who manages prediction and behavior ML at Zoox on the capacity blocks. They were able to run many experiments way beyond the timelines of the GPU schedules, and they were able to procure P4s and in terms of running those ML models. Right, now we have seen compute. Let's diverge a bit into storage. As Prasanna mentioned, there's a lot of data that is being collected from the vehicles, which includes the vehicle data and riders data. Storage plays a major role in terms of doing analytics and also processing and also the fine-tuning for all of the machine learning workloads. So S3 intelligent tiering is one of the option that Zoox adopted within the S3 as in their whole data lake, because Zoox has like this vast amount of data that is coming from all the vehicles and all the riders. So there's a lot of data which is on unpredicted patterns. So how do you manage these level of unpredicted patterns? Well, you deal with the storage over here that is with the sensors data and also for the analytics, but still there is an access pattern that is being much valuable, otherwise it will be a lot of cost prohibitive solution. So for that, Amazon S3 intelligent tiering plays a major role. It automatically detects your pattern and your usage of the data. In fact, it doesn't hinder anything regarding the performance of the data, but it will analyze the data, it will get to know what is the access pattern around that data, and then start moving the data to various other tiers. Here what we are looking at is, animation is not loading, I'm sorry. So the data starts moving from a frequent access tier to an infrequent access tier, and then slowly it gets to stages of a different archival processes, and that's how intelligently S3 manages an operability for you, so that you need not worry about how do you have to effectively manage your data and be a cost optimized solution. So S3 intelligent tiering takes care on that. And here is another quick feedback that we got from Albert Cheng, Robotaxi data platform, that how S3 really powers for them as their bedrock in terms of leveraging it for the entire data lake and entire analytics. All right, there's another storage that I wanted to really dive deep here today is, as Prasanna mentioned earlier, inference latencies and also the compute and performing all this model training has to be done within the less latencies. So for that, what we offer is Amazon FSx for Lusher. It is one of our highly scalable file system that is powered with millions of IOPS and that can sit right beside your compute in a way in which you need not worry about the latencies, so that it offers in such a way that both your compute and your storage are sitting next to each other, so that it will reduce a lot of latency in terms of your training times too. So FSx for Lusher is highly scalable, as I mentioned already, and it's a storage optimized. You could try finding it in both HDD and SDDs as well, and you could choose whatever works for you in terms of better optimized and cost. And another interesting factor is, as Prasanna mentioned earlier, there's a lot of data lake that gets created within S3. So you need a linkage system that can actually bring your S3 data directly onto your GPUs. And one of the capability that FSx offers is it's called as an S3 linked file system, so that all your data within the S3 is directly linked with your FSx and sits as in a file system within your GPUs. So any edits or any drafts on the data that you make, it is automatically synced through it. And here is a quick peek on that. Amazon FSx for Lusher sits right in middle of your EC2 and S3, so that all your S3 data is served as a file system to your compute. And here is a quick feedback that we got from Tom Larson. He's an engineering manager in Zoox, that how it powers their high performance compute workloads. Amazon FSx for Lusher creates as an POSIX system for them, so that it almost functioning as an intermittent operating system for them in terms of leveraging the data from S3 directly to your GPUs. All right. A little bit more on the storage now, but diverging a topic into the analytics mode. As we have seen, there's a lot of data coming again which resides in S3 buckets, and also there is necessity that you would have to make insights out of this data. As Zoox does a performance on logging and the metrics, there is a huge data that has to be visualized, and at the same time, the same data has to generate a lot of insights for you. And for that, Amazon OpenSearch service actually helps in terms of bringing these level of insights. And Amazon OpenSearch service is one of our capability that helps you to run your OpenSearch and manage it at a scale. It is actually powered with a lot of log analytics capabilities, and it is also offered at a serverless mode. And for the teams that they were trying to leverage with a lot of data that is coming through and wanted to search and generate log insights, or even perform your embeddings and use as a vector storage, we actually recommend Amazon OpenSearch service. So for Zoox, as stated earlier, there's a log data that is coming in. So for all of this log data, you need to have a sort of a log analytics that has to read through the text and generate a lot of insights. And that is one of the key use case which Zoox leverages Amazon OpenSearch service for. And there is also, because of the ML models and lots of training that's happening, there's a lot of vectors that gets generated, and it also requires to have a lot of semantic embeddings. And furthermore, with the nearest neighbor searches. And these two are the major use cases in which Zoox leverages today OpenSearch and starts supporting it at a scale. All right. While we know that there's a lot of data, information that is available regarding a lot of resources that we have already mentioned here, and as Prasanna mentioned earlier too, but we kind of curated our best resources in this session, so that is immediately effectively available to you, and where you can really get started. And some among them is like the capacity blocks, and there's also a capacity blocks walkthrough. And if you want to learn more about Zoox and understand about all the autonomous driving use cases and their entire releases, that information is available on Learn More about Zoox. With that, thank you all. We hope you'll have a great reInvent. And please feel free to check out on Thursday the replay party where the Zoox Robotaxi would be displayed. And thanks again for coming to this event. Yeah.